Hi, welcome back. This is 10.1 and we're going to be looking at geometry in this section. Okay, things that you've seen probably your whole education life. We have line, so here's a point AB, we draw a line through it. The symbol, this means line AB or line BA. We have a half line where we have a point and we draw the line in one direction, and this is the symbol. This means half line AB. Segment is we have 2 points, so the line doesn't keep going forever. It ends at these points, and the symbol is segment AB. Okay, we're going to look at an angle now. If we take two half lines and we intersect them at one point, we call that an angle. And the intersection is called the vertex. Okay? Now, if we label this, I'm going to label this A, and the vertex B, and then C. So how we would write the symbol for this, we could simply just say angle B, or we say angle ABC, where the vertex is in the middle, or we can say angle CBA, once again, as long as the vertex is in the middle. Okay, if we draw our two lines such that they make a right angle, and a right angle means this makes up 90 degrees. Okay, so we're going to call this a right angle. All right, so again, I'm going to label this A, B, and C. And the shortcut, we'd say the measure of angle ABC equals 90 degrees. Okay. Now, I know some of you are looking at your phone and you're taking screenshots of these notes. I highly suggest it gets better into your brain if you take your own notes so you have them to study and it looks more familiar to you. Okay, so if we took two right angles and we put them together, so here's one and here's another one, notice this would be 90 degrees and this would be 90 degrees. So basically what you can think of as a straight line going from here to here is 180 degrees. We just add 90 plus 90. Okay? Now, if we have a straight line and we make an angle, something that looks like this, we call these supplementary angles. So I'm going to call this angle, the big one, 1, and the small one, 2. And what we can see is the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And we say angle 1 and angle 2 are supplementary angles. Okay, angle 1 and angle 2 are supplementary angles. Okay, so let's say we take a right angle and we split it up. Okay, so I'm going to split this up. I'm going to call this angle 3 and this angle 4. Well, we can see that the measure of angle 3 plus the measure of angle 4 equals 90 degrees. And we say angle 3 and angle 4 are complementary angles. Okay, so now we're going to apply what we've learned and do some problems. Okay, so here are some examples. So let's say that we have, oops, make this, okay. So I'm going to say that this angle right here is going to be 32 degrees. And we're going to call this angle here x. And then we're to find x. Well, we know that these are complementary angles. So we know x, this angle, plus 32 equals 180. Because all of this, oops, I'm set 90 degrees. All right, so we're going to minus 32 from both sides, and we have x equals 58 degrees. All right, so let's do another example. I'm going to say this angle right here, let's say it's 13 degrees. Okay, and this angle right here, this big one right here, we're going to call it x. And what we know is 13 plus x equals 180. Okay, so we solve for x, minus 13 from both sides, and x equals 167 degrees. Okay, let's look at other types of angles. If we take two lines and we just intersect them, the angles that they make, here's one angle and here's another angle, we call these vertical angles. Vertical angles. Okay, notice they have the same measure. When they have the same measures, we say they're congruent. Vertical angles are congruent. This little symbol means congruent, and that means same measure. Congruent. Okay, it's an equal sign with a squiggly on top. Vertical angles are congruent. Do you see another pair of vertical angles in here? Very good, you do, right here. These are congruent. Now to show, because there's got so many angles in there, to show that these two angles are congruent, we can make one little dash here, and that means that those pairs are congruent. And then we can make two little lines here to say that these two are congruent. Okay, so now we're going to do an example. Okay, so here's an example. Draw a straight line. Okay, then make an angle of the line. We're going to call this angle 1, angle 2, and angle 3. And this right here, we're going to say this represents an angle measure of 133 degrees. Okay, so if this is 133 degrees, because we know vertical angles are congruent, we know the measure of angle 2 must also equal 133 degrees. Okay. Now, since also this is 133 and this is 1, and this right here, these two are supplementary angles, we know that 133 plus the measure of angle 1 must equal 180 degrees. Okay. So we get angle 1 alone, and we find out the measure of angle 1 by subtracting 133 on both sides is 47 degrees. Okay, so we figured out angle 2 and angle 1. Now what is angle 3? Well, that's easy. Angle 1 and angle 3 are vertical angles. So we can conclude the measure of angle 3 also equals 47 degrees. And that is just basically because vertical angles are congruent. Okay. These, we know, are called parallel lines. Parallel lines. Okay, I'm going to label this line L1 and this line L2. And a shorthand for writing parallel lines is we say L1 is parallel to L2. Okay? Now, if we make perpendicular lines, that's where they intersect at a 90-degree angle. Perpendicular lines. Okay, and the shorthand is L1. If I call this L1, is perpendicular to L2. Okay. All right, one more concept to go through, and then I will write down the homework for 10.1. Okay, what we're going to do is we're going to draw two parallel lines. Okay, I'm going to make these a little wider so we can see better what I'm about to do. So make them a little wider. Okay, so we have two parallel lines, and then we're going to cut through the parallel lines with another line. And we call this line a transversal. A lot of vocabulary in geometry. All right. Okay, so we cut through those parallel lines with a straight line. We call that transversal. Now what I'd like you to do is label the angles. So we're going to call this angle 1, this angle 2, this angle 3, and this angle 4. And now we're going to go down to this intersection right here, and we'll call this angle 5, angle 6, angle 7, and angle 8. Okay, so we're going to talk about the different names that we call these angles. So the first one is corresponding angles. Corresponding angles. Okay, corresponding angles. Those are angles that are on the same side of the cluster of angles. So here we have a cluster here, and here we have a cluster here. Look at this top left and this top left. We say they correspond to each other. So we're going to list our corresponding angles. Angle 1 and angle 5 are corresponding angles. All right. Now look at 2 is the far top right and 6 is the far top right. So we say angle 2 and angle 6 are corresponding angles. You see any more? Yes, of course. We see these bottom left, angle 3 and angle 7. And then we have these bottom right, 4 and 8. Angle 4 and angle 8. Okay. Now if you notice, if you look at angle 1 and 5, right here, they look like they have the same measure. Now in geometry we can never assume, but you don't have to worry about that because people before you have proved these things. And this is one thing that they have proven, is that corresponding, and I'm just going to write a short here, corresponding angles are congruent. That's right. So 1 and 5 equal in measure, 2 and 6 are the same, 3 and 7 are the same measure, and 4 and 8 have the same. Okay. All right, we have some more. Alternate. That says alternate interior angles. Alternate interior angles. All right. Well, of the transversal, alternate means they're on opposite sides. Interior means they're on the inside of the parallel lines. So alternate interior are these angles. 3 and 6 are alternate interior angles. So angle 3 and angle 6 are alternate interior angles. You see another pair? Of course you do. Angles 4 and angle 5. Angle 4 and angle 5 are alternate interior angles. Now, same thing here. Alternate interior angles. What do you think? That's right. They're congruent. Alternate interior angles are congruent. They have the same measure. Okay. Now, we have alternate, guess what? You're right. Alternate exterior angles. Very smart. Okay? So opposite, and they're on the outsides of the parallel lines. So let's list those angles. We have angle 1 and angle 8. Angle 1 and angle 8 are alternate exterior angles. Angle 2 and angle 7 are alternate exterior angles. And what do we know about alternate exterior angles? You are correct. Alternate exterior angles are congruent. Okay, so here's your homework for 10.1 homework. 11, 13, 25, 27, 29, and 31.